Hello dear student, so you know that we have started the gravitation for NEET classes, ठीक है ना बेटा? So this is our session number 4. Already I had delivered some 3 sessions. Okay, so in the first session we had discussed the Newton's law of gravitation. Then the session number 2 we had discussed the acceleration due to gravity. In the session number 3 we have done some PYQs, some previous year questions on Newton's law of gravitation and then the acceleration due to gravity. Now this is our session number 4. So here again we are with some PYQs. Okay, so some previous year questions. All right. Now the question is like this. Okay, so highly important question this one, ठीक है ना बेटा? तो आप ध्यान दीजिए बेटा. So question is like this, that there are how many particles? There are 4 particles, each of mass capital M, are placed at the 4 corners of a square of side R. Okay, let's give the side A, or you can take it R. Calculate the net gravitational force on one of the particles due to the remaining 3 particles. Okay, so there are how many particles? 4 particles, each of mass capital M, are placed at the 4 corners of a square, and you are supposed to calculate the net gravitational force on one particle. All right, so this, you know that this is superposition principle. Okay, so first of all let me make a diagram here. Okay, so we'll be starting with the diagram. ठीक है ना बेटा? Let's construct a diagram here. Okay, so let's first of all start with the diagram. If you are able to draw the diagram here of the question, the 90% of the question is almost done. तो यहाँ आप ध्यान दीजिए बेटा. Okay, so concentrate here. So we'll be starting with this. Okay, so here we have this is square. Let's take the square, its side is equal to A. All right, now how many particles are there? There are obviously 4 particles at the 4 corners. ठीक है ना बेटा? So this particle is here M, and this here another particle, ठीक है ना बेटा, that's equal to M, and this here we have another particle which is equal to M, and this is the 4th particle which is equal to M. All right, okay, now the question is like this, that you are supposed to calculate the force on one particle. Okay, let's suppose the particle is here, so we are supposed to calculate the force on this very particle. Okay, now you see, first of all, the step number first is that you will have to see how many pairs this particle makes, and with how many particles it makes the pairs. All right, now it's obvious that, for example, suppose that this is here A, this here B, this one is C, and this one is D. ठीक है ना बेटा? So obviously the C makes how many pairs? It obviously makes 3 pairs, one with the particle A, another with the particle B, and then with the particle D. All right, okay, तो आप यहाँ ध्यान दीजिए बेटा. So there a bit of geometry is there. What I will do is this, I will draw a diagonal here. ठीक है ना बेटा? Now this side is equal to A, so obviously this side is also equal to A. ठीक है ना बेटा? Then the length of the diagonal, you know that it must be equal to √2 multiplied by A. All right, so it must be equal to √2 multiplied by A. Simply using the Pythagoras theorem, PGT, we can calculate obviously. So if this side is A, this is A, so this will be equal to √2A. All right, अब देखो बेटा, how many forces will be there on the particle C? कितने force होंगे बेटा? So obviously there will be 3 forces. ठीक है ना बेटा? One force because of this D, another force because of this B, and another force because of this A. All right, okay, so let me draw what we call as free body diagram for the particle C. I will show all the force on this. So इस दिशा में एक force है बेटा, what is that? That's equal to F. इस दिशा में एक force है ना बेटा, that's equal to F. All right, and then there's another force in this direction, and let me label that as F dash. Let me label this as F dash. Why I am labeling this as F dash? Because this F dash and F will not be same. It will not be same in magnitude. ठीक है ना बेटा? Now F and F, they are mutually perpendicular. तो इनका resultant क्या आएगा बेटा? इनका resultant आएगा बेटा √2F, and that too in this direction. ठीक है ना बेटा? √2F. Okay, so how many force we have? 3 forces, F, F and F dash. ठीक है ना बेटा? I have calculated the resultant of the 2 forces, that's F and F. Since they are mutually perpendicular, तो इनका resultant जो आएगा वो क्या आएगा? √2 multiplied by F. Now you see that now there are 2 forces on the particle C. One is F dash, another is √2F. ठीक है बेटा? So this F dash and √2F, if you see it, they are parallel to each other. They are in the same direction. All right. So the net force here, let me write it down. The net force on the particle C will be simply equal. It will be equal to √2 multiplied by F and plus F dash. √2 multiplied by F plus F dash. All right. Okay, so let's try to calculate it. Okay, so using the Newton's law of gravitation, so the net force on the particle C will be simply equal to √2 multiplied by F. अब ये F किसके बराबर है बेटा? It is equal to G into product of masses, that's M square, divided by distance square, that's equal to A square. ठीक है ना बेटा? And what about this F dash? F dash is obviously equal to G multiplied by M into M is M square, divided by what is the distance here? The distance here, that's equal to √2A whole square. That's √2A whole square. ठीक है ना बेटा? Okay, next what I'm going to do is this. I will take the common. बोलो बेटा क्या common लेंगे? यहाँ से बेटा gm square by a square है. ठीक है ना बेटा? यहाँ से भी gm square by a square. So let me take this common, gm square divided by a square. gm square divided by a square. तो बचेगा क्या बेटा? यहाँ बचेगा √2. And what about this? This will be here 1/2. ठीक है ना बेटा? So we are done with the problem. Okay, so this is the answer to the problem. ठीक है बेटा? It's equal to gm square by a square. यहाँ आएगा बेटा √2 and this √2 square is 2, so obviously it will be equal to 1/2 and hence we are done with the problem. All right, okay. Now next what I will do is this, we'll switch to another example. So I'm sure आपको अच्छी तरह से समझ में आया होगा. You can take the screenshot of this, okay. Then let's switch to another example. Let's switch to another example. यहाँ आप ध्यान दीजिए बेटा. So let's switch to another example, okay. So this was our question number 8. So let me show you the question number 9 here. So here we are. Another question is example number 9, highly important example, and that too asked in the AIPMT 2019. ठीक है बेटा? So this question has been asked in the AIPMT 2019. So concentrate on this. आप यहाँ ध्यान दीजिए बेटा. So this question has been asked in the AIPMT 2019. Okay. So this is our question number 9. All right. यहाँ ध्यान रखो बेटा. So here it is. The question is like this. There are how many objects? First of all, you see the question clearly. There are two spherical objects of mass m and 2m. What is given to you is this. This is m and this one is 5m. Sorry, m and 5m. And what about the radii? The radius r and 2r. Radius r and 2r are released in free space with initial separation between their centers 12r. So this 12r is also important for us. If they attract each other due to the gravitational force only, then the distance covered by the smaller body before the collision is smaller body. Smaller body means which body? Smaller body means this m. You are supposed to calculate the distance covered by the m just before the collision. ठीक है ना बेटा? And this question has been asked in the AIPMT 2015. Okay, so let's try to work it out. Step number first, draw the diagram. Step number first, draw the diagram. Once you are able to draw the diagram, the 90% problem is done for us. ठीक है ना बेटा? And without constructing the diagram, you cannot do this problem. Okay, you cannot do this problem. Okay, so let's try to work it out. अब यहाँ ध्यान दीजिए बेटा. So let's try to work it out. So here it is. So this is what I'm going to do. This is what I'm going to do. First of all, I'll make a diagram. So how many particles are there? There are obviously two particles. ठीक है बेटा? So this one particle and this another particle. ठीक है ना बेटा? इस particle का जो mass है बेटा that's equal to m, और इस particle का जो mass है बेटा that's equal to 5m. इसका जो radius है बेटा that's equal to r, और इसका जो radius है that's equal to twice r. That's what's given to you. This is the data that's given to you, and the separation between them is equal to 12r. What is the separation between them? That's equal to 12r between their centers. Okay. Now obviously there will be gravitational force of attraction between them. That's obvious. ठीक है ना बेटा? So when there's gravitational force of attraction between them, so the two particles will attract each other. So they will accelerate towards each other. And finally, what can happen is that they will collide. ठीक है ना बेटा? What can happen is this. They will collide. Okay. So the final snapshot I'm going to make it here. यहाँ मैं एक final snapshot बनाऊंगा बेटा. Like this it is. So this here one particle and this another particle. All right. So these are the two particles. And this is the final snapshot. ठीक है ना बेटा? Finally, they are going to collide like this. Now you tell me what will be the final separation between their centers. You tell me what will be the final separation. ठीक है ना बेटा? तो जो ये particle है बेटा, इसका radius क्या है बेटा? That's equal to r, isn't it? And what about this particle? इसका जो radius है बेटा, that's equal to twice r. Twice. Now you tell me what was the initial separation between the two particles. What was the initial separation between the two? That's obviously equal to 12r. That is given to you. That's given to you. The initial separation between their centers was what? That was 12r. It is given to you. Finally, when they will collide, okay, the separation will be r plus 2r, and what's there? That's equal to 3r. All right. So from this, what you can calculate is this: what is the distance covered by both the particles combinedly, and what their distance will be. Let me write that x here. That will be obviously equal to 12r minus 3r, isn't it? Because the initial separation was 12r and the final separation is 3r. The difference of the two will be what? That will be equal to 9r. All right. ठीक है ना बेटा? So final separation is what? 9r. But we are not supposed to calculate the 9r. We are supposed to calculate what will be the distance covered by this particle. इस particle ने कितनी distance complete cover की होगी बेटा? So let me assume that that's equal to r1, and the distance covered by this will be equal to r2. All right. And what we are supposed to calculate is the value of this r1, r2. ठीक है ना बेटा? So let me calculate only r1. ठीक है ना बेटा? Because you are supposed to calculate the distance covered by the smaller body, and smaller body means that small m. Okay, capital M. Okay, so what I will do is this. यहाँ आप ध्यान दीजिए बेटा, इस पर एक फोर्स है बेटा, isn't it? And that is for example F1. ठीक है ना बेटा? इस पर एक फोर्स है बेटा, that's equal to F2. Now you know that this Newton's law of gravitation, it obeys what? It obeys Newton's third law of motion. And what is Newton's third law of motion? That is, to every action there is an equal and opposite reaction. And what we mean by that? That means जो ये F1 है और जो F2 है बेटा, इनका magnitude same होगा, but the direction will be opposite. F1 you see it is directed towards right, and F2 you see that is directed towards left, but their magnitude will be exactly same. If F1 is 10 Newton, F2 has to be 10 Newton, isn't it? यहाँ ध्यान दीजिए बेटा. So what does that mean? That means this force is equal to mass into acceleration, isn't it? This Newton's second law of motion, that force is equal to mass into acceleration. ठीक है ना बेटा? This force is equal to mass into acceleration, okay? तो हमारे पास क्या है बेटा? Force is equal to mass into acceleration. All right, okay. Now this is a constant for both the particles. The force is constant for both the particles. From there, what I can say is this acceleration is proportional to 1 divided by m, isn't it? Isn't it? तो इसका मतलब क्या है बेटा? जो लाइटर पार्टिकल होगा उसकी एक्सेलरेशन ज्यादा होगी और जो हैवियर पार्टिकल होगा उसकी एक्सेलरेशन कम होगी, obviously. For example, there are two particles, like there is an electron and there is another particle, like for example there is a proton. You know that the electron is a lighter particle and hence active, and the proton, there is a heavier particle that's a bit bulky and hence lethargic as well, and the distance covered by the proton thereby will be less. ठीक है ना बेटा? Now acceleration is inversely proportional mass. It in turn implies that the velocity is proportional 1 divided by m. ठीक है ना बेटा? जो हैवियर पार्टिकल होगा बेटा उसकी वेलोसिटी कम होगी, जो लाइटर पार्टिकल होगा बेटा उसकी वेलोसिटी ज्यादा होगी. दिस इन टर्न implies that the distance covered by the particle will be again inversely proportional to m, will be again inversely proportional to m, isn't it? ठीक है ना बेटा? Okay, now check it out. यहाँ ध्यान दीजिए बेटा. So what I will write down is this: r is proportional 1 divided by m. Now this equation in turn implies that this r1 is to r2 will be equal to m2 is to m1. ठीक है ना बेटा? Obviously the reason is that they are inversely proportional. Lighter particle will move faster, so the distance covered by the lighter particle will be more. Okay, as simple as that. ठीक है ना बेटा? Now you are supposed to calculate what? You are supposed to calculate the value of r1. So you can safely calculate it. r1 will be equal to, its factor is here, m2. ठीक है ना बेटा? Divided by summation of these two numbers. What's that? That's m2 plus m1. m2 plus m1, all right, multiplied by the net distance, that will be equal to r. All right, okay. So m2. अब यहाँ ध्यान दीजिए बेटा. Okay. So let's go back to the question. Now this particle here is m1 and this particle is what? That is m2. Now you see that m1 is equal to m and m2 is equal to 5m. Okay. So let's try to work it out. यहाँ ध्यान रखो बेटा. m2 किसके बराबर है बेटा? m2 is equal to 5m. And what about m1 and m2? m2 is equal to again 5m. ठीक है ना बेटा? And what about this m1? That's equal to m multiplied by the net distance covered by the particles. Net distance covered by the particles. Here we have calculated that that's equal to 9r. The total distance covered by both the particles is what? That's 9r. That's 9r. ठीक है ना बेटा? अब यहाँ ध्यान दीजिए बेटा. So here it is 5m, isn't it? Then here it is 5 plus 1. That's equal to 6m. And then here it's 9r. ठीक है ना बेटा? And this m and m is going to cancel. So this is something like 5 by 6 into 9r, something like this, 5 divided by 6 multiplied by 9r. All right, so this is what will happen is this, 3 2s are 6, then here 3 3s are 9, 5 3 15 by 2, 15 by 2 is 7.5, तो क्या आएगा बेटा? 7.5 multiplied by r. So this is your answer. ठीक है ना बेटा? Now let's go back to the problem. Is there any option there? So let's see the problem whether there is any option like 7.5 r. Okay, ठीक है ना बेटा? So this is your problem. So this is the answer, that is 7.5 r. This is the answer, which is equal to 7.5 r. Okay, all right. So this is the answer. ठीक है ना बेटा? So answer will be 7.5 r. Okay. So I'm sure it is clear to you. I'm sure it is clear to you. ठीक है ना बेटा? For you, what I will be doing is that we'll be going back to the problem. So this was your problem. All right. Okay. So this was from we started. ठीक है ना बेटा? So again, I'm going to explain it because it's highly important problem. ठीक है ना बेटा? And this question can be repeated in the electrostatics as well. This question can be repeated in the center of mass as well. ठीक है ना बेटा? And this has been asked in the gravitation. ठीक है बेटा? Okay. So how many particles are first of all there? There are obviously two particles, m and 5m. All right. And the radii are given to you. This its radius is r. Radius of this particle is what? That's equal to 2r. Initial separation between the centers, that's equal to 12r. Now the question is like this: these particles will attract, they will accelerate, and finally they will collide with each other. Now you are supposed to calculate what will be the distance covered by the smaller particle just before collision. All right. Okay. So this will be the final snapshot when the two particles will collide. When the two particles will collide, इसका radius होगा बेटा. इसका radius है r and its radius is 2r. So what is the final separation between them? That's r plus 2r is 3r is the separation between centers. What was the initial separation? 12r. So what is the distance covered? Simply initial separation minus final separation. And what's that? That's equal to 9r. What we are supposed to calculate is this: what is the distance covered by this particle? All right. Okay. So what I've done is this: simply ये equation आपको याद रखनी है बेटा. R is proportional 1 divided by m. जो ये वाली equation है ना बेटा, this is what this actually what this is Newton's second law of motion. What is this Newton's second law of motion? ठीक है ना बेटा? And what about this equation? This actually momentum conservation. What is this? This is momentum conservation. ठीक है ना बेटा? This one. And what about this? This actually definition of center of mass. This definition of center of mass. ठीक है ना बेटा? The two particles will collide with each other and will collide at the center of mass of the two particles. All right. Okay. So then from this free equation, what I'm going to do is this. What I'm going to do is this. That R is proportional 1 divided by m. R1 is R2 is equal to m2 is to m1. Then a simple mathematical equations here. Okay. Okay. So 5m divided 5m plus m. That is 6m. This m and m is going to cancel. Then simply it is 3 2 6, 3 3 9, 5 3 15 by 2, 15 by 2 is 7.5. और तो ये निकलेगा इसका आंसर. ओके, सो हाईली इंपॉर्टेंट प्रॉब्लम. ठीक है ना बेटा? नाउ लेट्स स्विच टू अनदर एग्जांपल हियर. लेट्स स्विच टू अनदर एग्जांपल. सो दिस वाज आवर क्वेश्चन नंबर 9. ठीक है ना बेटा? लेट्स स्विच टू क्वेश्चन नंबर 10 हियर. क्वेश्चन नंबर 10 वाज आस्क्ड इन नीट 2017. आई एम श्योर यू कैन डू इट इजीली. इसमें कोई कैलकुलेशन करने की कोई जरूरत है ही नहीं. सो इट्स अ कॉन्सेप्चुअल क्वेश्चन एंड द क्वेश्चन इज लाइक दिस. यहां ध्यान दीजिए बेटा. सो द क्वेश्चन इज सिंपली लाइक दिस. देयर आर टू एस्ट्रोनॉट्स. They are floating in a gravitational free space, which is highly important for us. What's important for us is this gravitational free space. ठीक है ना बेटा? After having lost contact with their spaceship, so they are, for example, in the space and they are lost their way to the spaceship, and they are supposed in a space where there is no gravitational force at all. ठीक है ना बेटा? The two will. Now the question is two will. Okay. The option number A is what? Move towards each other. Option number B, they will move away from each other. Option number C will become stationary at some point. Option number D will keep floating at the same distance. They will keep floating at the same. Now it's obvious like this. For example, suppose that let's imagine like this. This is that frame of reference. ठीक है ना बेटा? This is some space where the acceleration due to gravity or the gravitational force is simply equal to 0. That means the external force will be equal to 0. Now there are two astronauts like this. So for example, here we have this one astronaut and here we have another astronaut. ठीक है ना बेटा? So obviously they will have mass. They will have mass. Suppose the mass of this is m1. Suppose the mass of this is m2, and the separation between them is r. Will they attract each other or will they repel each other? Obviously they will attract each other. The reason is that gravitational force is always attractive in nature. So when they will attract each other, so because of that they will move towards each other. That's it. The problem is done. ठीक है ना बेटा? Obviously. Okay. So there's no rocket science in it. ठीक है बेटा? Next, let's switch to another example. Let's switch to another example. यहाँ ध्यान दीजिए बेटा. Okay. So let's switch to example number. Okay. So we're done with the examples. Yeah, we're done with the examples. Let's do some examples on this, which is what we call as gravitational superposition principle. You just wait a moment. Okay. So let's switch to this. यहाँ ध्यान दीजिए बेटा. Okay. So next what we'll be going to do is this. We'll be going to solve the problems. We'll be going to do the examples on the acceleration due to gravity. Okay. So this example number 1 and this example number 1 has been asked in the AIPMT 2012. ठीक है ना बेटा? आप यहाँ ध्यान दीजिए बेटा. So the question is like this. So this question has been asked in the AIPMT 2012. Simply question आपके पास है क्या बेटा? A spherical planet is there, has the mass capital M and the diameter D. A planet of mass small m falling freely near the surface of this planet will experience acceleration due to gravity equal to. You are simply supposed to calculate the acceleration due to gravity. And what is given to you is that the radius is diameter is given to you, not the radius, diameter is given to you, and the mass of the planet is given to you. All right. Okay. Then what you know is this. What you know is this. For example, ये हमारे पास एक planet है बेटा. ठीक है ना बेटा? Okay. So its mass is capital M. All right. Its diameter is given, that is equal to D. ठीक है ना बेटा? At this very point we are supposed to calculate the acceleration due to gravity. You know the equation for the acceleration due to gravity, that's simply like this: gm divided by r square. ठीक है ना बेटा? gm divided by r square, where what? M is the mass, g is the gravitational constant, r is the radius. All right. Next what I'm going to do is this. Since radius is not given, diameter is given. So simply it's like this: gm. ठीक है ना बेटा? r के बदले क्या लिखेंगे बेटा? diameter divided by 2 whole square. ठीक है ना बेटा? So 2 square is 4. So what it will be is this: 4 gm divided by d square. तो ये रहा इसका आंसर. ठीक है ना बेटा? Okay, not that difficult problem. It's quite easy. Simply radius, you have to replace the radius by the diameter divided by 2. तो 2 का square आएगा बेटा 4, so it will be equal to 4 times gm divided by d square. All right. Okay. Let's switch to another example. ठीक है ना बेटा? So this is your example number 2. This is your example number 2. Example number 2 is simply like this. The value of acceleration due to gravity reduced to half its value at the surface of Earth at height h. Then you are supposed to calculate what will be the relation between this h and r. What is the relation between h and r if the acceleration due to gravity reduced to half? ठीक है ना बेटा? Okay, so let's work it out here. यहाँ आप ध्यान दीजिए बेटा. Let's work it out here. Okay, so the question is simply like this. What is the question is this? You know that the acceleration due to gravity, it varies with the height, it varies with the depth, and decrease both with the height as well as depth. And then you know this equation, that acceleration due to gravity with the height is equal to what? It's equal to g into r square divided by r plus h whole square. ठीक है ना बेटा? This is a generalized equation for what? The acceleration due to gravity at a height h. Now what is given to you is that the acceleration due to gravity reduced to half. So that means it becomes simply g divided by 2. It becomes g divided by 2. Reduced to half means that it becomes g divided by. Now you are supposed to calculate the value of h in terms of r. So simple calculation beta, g and g will cancel first of all. ठीक है ना बेटा? Then it's something like this, r divided by r plus h whole square, isn't it? Is equal to what? That's equal to 1 divided by 2. All right, g and g will cancel. Then here it's r square divided by r plus h whole square. Then this is what you can write. ठीक है ना बेटा? You are in search of this h. So what I will do is this. I will write down here r divided by r plus h is simply equal to 1 divided by root 2. Simply what I have done is that I have taken the square root on both the sides. Then square root of this square and root will cancel. Then here it's 1 divided by root 2. What I am in search of is this h. ठीक है ना बेटा? Cross multiplication. So root 2 multiplied by r will be equal to r plus h. ठीक है ना बेटा? I am in search of this h. So root 2 multiplied by r minus r will be equal to h. ठीक है बेटा? So h will be equal to what? Take this r common. It will be root 2 minus 1. This is the answer. ठीक है ना बेटा? तो ये रहा आपके पास आंसर. ओके, ठीक. We are done with this problem. Easy है बेटा. gr square divided by r plus h whole square. Then it is g divided by 2. अगर आपको याद होगा बेटा, there is a shortcut technique for this as well. There is a shortcut technique for this as well. And that's like this. If gh becomes equal to h by m. यहाँ आप ध्यान दीजिए बेटा. If it becomes g divided by m. If it becomes, for example, g divided by n. ठीक है ना बेटा? If it becomes g divided by n, in that very case, this h is simply equal to r into root of, sorry, it's like this, into root of r into root n minus 1, simply like this. ठीक है ना बेटा? If for example you memorize this equation directly, then what you can do is this. यहाँ आप सिर्फ n देखोगे. What is that n? That's equal to, so simply substitute it here. It is root 2 minus 1 multiplied by r, and finally that's the answer. So you can avoid all this calculation if you memorize this result directly. ठीक है ना बेटा? So important result this one. ठीक है ना बेटा? You can save it here. Okay. Next, अब यहाँ ध्यान दीजिए बेटा. Next क्या है? So this was your example. So this was your example number 2. So इसका आंसर जो है बेटा. So here I am writing that down. So what is the value of h here? That h is simply equal to what? That h is equal to what? That's equal to root 2 minus 1 multiplied by r. This is the answer to the problem. All right, ठीक है ना बेटा? Let's switch to another example. Okay, this is the last example we'll be doing. This is the last example we'll be doing. यहाँ ध्यान दीजिए बेटा. So the example is like this. Acceleration due to gravity at the center of Earth is. What is the acceleration due to gravity at the center of Earth? Obviously 0. ठीक है ना बेटा? So this, for example, suppose that this Earth. यहाँ ध्यान दीजिए बेटा. This is the center of the Earth. This center of Earth. For example, this point O, and this is the surface. Acceleration due to gravity at the center of Earth is 0. As you move from center to surface, acceleration due to gravity increases. As you move from surface onwards, the acceleration due to gravity again decreases. ठीक है ना बेटा? अगर आपको ग्राफ याद होगा बेटा, that graph will be something like this. The variation of acceleration due to gravity with the radial distance from the center of Earth. At center of Earth, acceleration due to gravity is equal to 0. What is that? 0. At this very point, the acceleration due to gravity is maximum, and that value is 9.8 meter per second square. So as you move from center to surface, the acceleration due to gravity value, it increases. Then as you move from surface onwards with the height, the acceleration due to gravity again it decreases. It decreases. ठीक है बेटा? So the graph is somewhat like this. Linear graph increases up to the surface. So this here small r equal to capital R. Up to the surface it increases, and thereafter it decreases like this. The graph is a straight line inside and a rectangular hyperbola outside. So the answer was this, that what is the value of acceleration due to gravity at the center of Earth? So the answer is simply this, that is equal to 0. All right, okay, so we'll be stopping here. ठीक है ना बेटा? In the next session, we'll be continuing with this acceleration due to gravity with more examples of acceleration due to gravity. Then after that, we'll be dealing with what we call as Kepler's laws. Okay, so you take care of yourselves.